If you've ever tried to calculate the stress intensity factor in Abaqus, you've probably seen the mysterious contour integral option, but no one really explains what it actually does. In the next few minutes, I'll break down step by step how to set it up and how to interpret the results using an example of single edge notch tension sample. By the way, if you want to skip the simulation and download the files directly, check the link in the description. Let's get it started. Alright, now we go to the part to create the model. It should be 2D planar, deformable, shell, and 200. We click on continue. So the model we're going to create is like this. So this should be 100 by 50.8 and we have the crack of 25.8. So let's create this. We can create something like this. We have our sketch here. This should be 100 and this can be 50.8. Let's double check that. Yes, and we click on the scroll button of the mouse once more and done. Boom, we have our model. Simple as that. Okay, let's go to the property. We need to go here, create material, and the material is steel. From general density, we need to input density 7.8 E-9, and from mechanical elasticity and elastic, it should be 200,000 and 0.3. Now we need to create the section. This is very important. Please don't skip this. In section, even though we are having a shell deformable, we should create our section with solid homogeneous. I already explained that in the video you see on top part here. You can go ahead and check it out. Okay, solid homogeneous and continue. Here we have the material as the steel and we should have the plane stress / strain thickness and the thickness is 25.4. So in this case we create the thickness and now we need to assign the section. This is the last part. I uncheck this one in order not to create too many sets and done. So click on OK here and as it turns green it means the section is assigned. Now we need to go to the next one, which is assembly. This is so simple. Create assembly. I would like to make it independent. So click on OK. Now we can move our model to here, which is the 000. So translate instance, this one. Select this one and we can put it here. Now if we reset that view, we have the access here, which is totally optional. Okay, we need to go to the next one, which is step. In step we create a step here, static general, and we accept everything is here, incrementation and stuff. It should be fine for this one. Then we need to create field output and history output after we created the crack in the interaction. So we need to go to interaction. Please pay attention. This is very crucial here. If you don't do it correctly, you're gonna fail the simulation. So first of all, we need to create some partition. From tools here, you can go to the partition and create this one, face. Then you can go for sketch. Here we create a crack just like this. Then we need to put the value of 25.4, then OK. Now we click on the scroll button to create the crack. Now we need to create some partitions in order to have a better mesh. So again, from tools and partition, face, sketch, we should create a circle here, something like this. Let's have 7.9 for this circle and OK. Now we need to create another one, so I already click on that. We need to create, oops, hit Control Z, we can undo that. Okay, we need to create some lines here. They should be 16.8 apart from the center of the circle. One more just like this. We should make sure that it's 16.8 apart, which is correct. And we need to create another line here, something like this. This one also should be 16.8 apart, so 16.8 apart from the center of the circle. Then done, and the model should be something like this. Now we need to go from special, crack, and assign seam. So we select this one, then hold shift and select this one in order to select the crack, and done. Now we just created the seam. Okay, now let's go and create the crack. Here we can create a crack, contour integral, and we select the crack front, which is this one. Then we use the Q vector, and we use this one. We use this one first, then this one, and we have selected the Q vectors 0, -1, 0, and we need to go to singularity and make this one 0.25, and we can select the collapse element side single node for this guy. Alright, let's check the crack once more. This is the crack, and this is the propagation line. That's okay. Now let's go back to step in order to define the field output and the history output. So here I'm going to select this one, and we choose crack 1. Let's have every n increments, and number of contours I would like to have 6, and stress intensity factor, maximum energy release rate, and we click on OK. This is the history output, and now let's go to the field output manager and edit. Okay, this is the default and we accept that, and that's okay. Now we have done interaction and step. Now let's go to the load. Okay, here we need to create a load. I want to put this on step 1, and let's have pressure here. Select this one, hold shift and select this one, done. And as this is pressure and we want to have tension, we should put the minus sign here, -15.5, so that we have tension here. And we need to create a boundary condition in step 1, this one, and we select this side, hold shift to select the other line, and in cast. So it is in cast from this side, then it is being pulled from the other side. Alright, simple as that. Load is created. Now it's time to go to the mesh. Okay, we need to change some parts here. For the crack front, we click on OK, quad dominant, but this time we need sweep. So this is sweep mesh, and on the other side, these are all can be quad, medial axis, and free. Then OK. Now we can set this one on, let's say 2, and mesh it. And as you see, we have a good mesh here, but if we want to make it even more accurate, we can put this one on 1, and as you see, it would be very fine mesh, so it increases the cost of the analysis, and even 0.5 would be better. Let's see that. I will show you a job with this 0.5 and we compare that to this one we're having. Okay, I will put this one on 2 for now because it is okay. Now we need to change the family of the element. So we select this one and we need to go here and put this one on plane strain and uncheck the reduce integration, and it should be quadratic to be very accurate. And okay, we selected this one. Now we need to create a job. So from the job manager, I'd like to create a job named SENT contour integral, then continue, okay, and submit the job. If you enjoyed this video so far, please write a comment down below for me. It's totally free for you, but it helps me a lot to grow. Thank you very much. Okay, this is the results. Let's take a look. 1.2 E3 here, and let's zoom in, and here we have this contour. And if we take a look at the animation, oops, let's make it very slow, and I think, yeah, it should be like this. Now let's take a look at the results with 0.5 global size for mesh. Okay, as you see here we have 2.4. It means there's like 100% error in this one, which is pretty crazy. So we have to use the finer mesh. As you see here, we have to zoom in a lot to see the contour here, and I want to zoom out. Let's go for ODB history output and continue. Here we can select this guy's stress intensity factor here, and if we plot this, we have the plot of stress intensity factor versus time, which is pretty cool. And that's it for now. Congrats on mastering the stress intensity factor with contour integral. Right now you can make it more accurate and see the crack propagation with XFEM model. So click on the video on screen before it ends, and I see you there.